Okay, third time's a charm, folks. Hey, welcome. And we're going to go over the answers to the worksheet I gave you on limiting reactants with moles only. This is a division of like the stoichiometry that we've been studying, but it's just only a portion of it because it has to deal with the limiting reactants, and we're not going to use grams, just moles. Okay, remember limiting reactant is also the same as limiting reagent, all right? So how you want to tackle these? First things first, this does not have a balanced equation. And we need a balanced equation because we need to know what are the quantities, the ratios of the reactants versus how much product that we're going to form. So in this reaction, we have iron chloride reacting with oxygen to form iron oxide and chlorine gas. Okay, I've simplified the names, but that's okay. Like it's iron 3 chloride. That's okay. So just as a review, when we do these problems, most of the time we don't deal with the atoms that are by themselves in some point, because you can always adjust them without affecting something else. So you want to start with the atoms that are with something else, because then if you change one, you can adjust these later. All right. So right off the bat, we notice there's 2 irons here, 1 iron here. Let's make that a 2. Okay. That changes the chlorine. 2 sets of 3 means you have 6 chlorine atoms. So you're going to need to make 6 over here. I just like making these rainbow lines. And we're good to go with the chlorine. Now we need to look at the oxygen over here, and we're like, oh, snap. We have 2 here and 3 here. So we need to make them equal each other. So what you need to do is think of a number that they both can multiply to equal. And the nearest number is 6. So you multiply the 3 by 2, and the one that's 2 by 3. And that's great for the oxygen. However, it changed the irons. So we need to jump back here and go, okay, instead of 2 irons, we need 4 out front for 4. Now we've changed the chlorine. Don't worry, we'll fix it. 4 sets of 3 is 12. And if we go over here, we're going to go, okay, we need to go change that from 3 to what? 6, right? Because 6 sets of 2 is going to give us 12 chlorine. Okay, great. Now we have a balanced equation. So 4 atoms of iron chloride combined with 3 molecules, I should say molecules of iron chloride, combined with 3 molecules of oxygen and form 2 molecules of iron oxide and 6 molecules of chlorine gas. This also could mean moles, because moles are sets of molecules. So 4 moles of iron chloride will react with 3 moles of oxygen to form 2 moles of iron oxide and 6 moles of chlorine gas. So we can use that to determine the quantities that are going to be produced and react. So how many moles of chlorine gas can be produced if 4 moles of iron chloride react with 4 moles of oxygen? Well, right off the bat, you can see that since the coefficient here is 4, it means 4 sets of iron chloride, 4 moles of iron chloride are going to react with 3 moles of oxygen. Okay, so if all of the 4 moles of iron chloride reacted, we would only need 3 of the moles of oxygen. So oxygen is going to be in excess. The iron chloride is going to be your limiting reagent or limiting reactant, because that's one that's going to limit the amount of product that you can make. You're going to run out of this one first. Now, to show you how that works calculation-wise, let's pretend we don't see this very obviously and say, let's take our 4 moles of iron chloride, and we're going to use these coefficients and create a molar ratio that we're going to multiply to just convert this amount of moles and see how much oxygen is needed to react with it. So we want oxygen, moles of oxygen, as our units when we get done. There we go. So we're going to get rid of moles iron chloride. Okay, so that needs to be on the bottom because those units will cancel out because we like to do unit cancellation. And then the 4 on the coefficient for the iron chloride goes on the bottom, and then the 3 for the oxygen goes on top. Okay, so then what you would do is multiply straight across. Units cancel out, and you end up with 12 fourths, which simplifies to 3 moles of O2, right? Which you could have also just said, oh, those 4 moles up on top, on the bottom and the top cancel out, and then you're left with 3 moles of oxygen, but that's okay. So yeah, indeed 3 moles of oxygen is needed, and then you would compare it with the 4 moles of oxygen, and you'd say, cool, then I know that that 4 moles of iron chloride is the limiting reactant, and the excess reactant is the oxygen in this case. All right, so let's do a problem where it's not super obvious, okay? That's the second problem here. We're just going to do 2 problems using the following balanced equation. Thank you for balancing that equation. And then we're going to find out if 7 moles of the C2H6 react with 45 moles of O2, how many moles of water will be produced? So this time we're interested in how much water that's going to be the product that's going to be produced. You don't need that 2 there, so sorry. Okay, so there's a couple ways to do this. Since they're asking for moles of water, though, really we want to take the moles of C2H6 that we have and convert it to moles of water. And then take your moles of oxygen and convert it to moles of water, okay? So let's try that. We need to do 2 conversions this time, okay? So leave enough space. 7 moles of the C2H6 are reacting. Okay, let's get our molar ratio. This time we're really interested in these coefficients of C2H6 and the H2O. Looks like 2 moles of C2H6 react and 6 moles of water is formed. That's, of course, if you have plenty of oxygen. So the moles of the C2H6 go on the bottom and moles of oxygen go on the top. And, oh, I'm sorry, we're not doing oxygen this time, we're doing water. Oops. There we go. So the 6 goes with that, and the 2 goes with C2H6. Okay, so we know we got the right units because the units that we don't need cancel out, and the units we're looking for are left, which is moles of water. Okay, so this creates a ratio of 42/2. So we have 21 moles of water being formed by that 7 moles of the C2H6. By the way, that's ethane. Okay, super great. So now next time, we want to do this, or the second part, with the 45 moles of O2. So moles of O2 go on the bottom, because we're trying to get rid of moles of O2, and moles of water go on the top, because that's where we're trying to go towards. So let's put these coefficients as a molar ratio. 6 moles of water is produced with 7 moles of oxygen this time. So 6-to-7 ratio. Yeah, that's kind of a weird ratio. Okay, so we would take 45 times 6, divide it by the 7, because you take the top divided by the bottom when you're done with this, and you're going to end up with moles of H2O. I had to do this on my calculator, and I got 38.6, which rounds to about 39, but that's okay. Either way, we need to take these 2 quantities and compare them. The one that makes the least quantity will be your limiting reactant, since it's going to limit the amount of product formed. So the 21 moles of H2O is all we're going to be able to make, because that's all that the 7 moles of the C2H6 is going to be able to provide you. And we have plenty of oxygen, we have excess oxygen, so the limiting reactant is C2H6. There we go. And the excess reactant is the oxygen, again. All right, and then the answer to how many moles of water would be produced would be 21. So that's going to be your answer to that problem. Okay, thanks for joining us, and I hope that helped. Of course, privately message me your questions, and I'd love to answer them. Anyway, hope you're having a great day, and we'll talk to you soon.